Okay, gang, now continuing with our discussion of one-to-one functions and inverses, I want to do a few more examples from the activity. Hard to see this in this light, but number 3 asks you to find a formula for H inverse. This is in part 2, and H is given with this rational function formula. Number 9 asks you to find a formula for H of H inverse of X, and number 10 asks to sketch the graph of Y equals F inverse on the same axes with F of X. Let me come back to the board and let's see, open this up a little bit and see if I can get these examples done. Yeah, so these are, here is the function definition for H of X in activity 8. Rational function 12 over x minus 1. And in part 2, number 3, it says find a formula for H inverse of X. Here is an important part of the homework, finding formulas for inverses. So I'm going to use this example to introduce this idea, and I'll try to kind of go slow enough for you to catch this. I want to write H of X as in just equation form. So here's H of X as in function notation. As an equation in X and Y, that's just Y equals 12 divided by the quantity X minus 1. Okay? So that's an equation for this relation. Now I want to come up with the inverse of this guy. And the inverse relation is just what you get when you exchange input and output, right? Exchange X and Y. And in an equation, you can get that just by rewriting Y as X and rewriting X as Y. So every place that I see a Y, I'm going to write X. And every place I see an X, even if I see it in multiple locations, I'm going to write Y. Interestingly enough, this very, very quick step already gets me to the inverse. This is an equation for the relation. Reverse the roles of X and Y, and you have an equation for the inverse right there. But the hard work comes now, because in order to express H inverse of X as a formula, a function formula, I need to isolate Y. I need Y equals like this, because the H inverse function is actually this output variable Y. So now I've got some algebra. I've got to solve for Y, and sometimes that takes a few steps. Here I'm looking at a rational equation, right? I've got Y in the denominator. So you might recall from Math 95 or Math 70 that when you have an equation like this, you're trying to solve for a variable in the denominator, you're going to want to multiply both sides by the least common multiple of the denominators, or the least common multiple of the factors in the denominators, the least common denominator. So I'm multiplying both sides of this equation by Y minus 1, the quantity. And over here, of course, I get nice cancellation, and I'm just left with 12. But on the other side, I get X times the quantity Y minus 1. You might be tempted to distribute that, which wouldn't be incorrect, and you could still get to the answer. But I think I want to leave it alone for now. I'm trying to isolate Y, and I would like to get this X away from the Y. So let me leave it in this form and then divide both sides by X. So I get Y minus 1 equals 12 over X. And then add 1 to both sides. So you write down the original formula, H of X, as an equation. Change the role of X and Y. Every Y becomes an X, every X becomes a Y. That's the easy part, gets you to the inverse. And then isolate Y in order to get the formula you're looking for. And that means that H inverse is this formula. do another example or two like that in a minute. Further down the page, it asks you to come up with a formula for h of h inverse of x. Notice this is a composition. It's not written with the composition notation, but it could be. This is the same thing. Same thing as h, oh boy. Same thing as h composed with h inverse of x. H of h inverse of x. Okay? So this is h of, I want to always start from the inside and work out. H inverse is 12x, 12 divided by x plus 1. So h of h inverse is h of that formula. And then h is, you see way over here, is 12 over the input minus 1. So this is going to be 12 divided by this entire mass minus 1. So you'll get a lot of, when you do the algebra on these, you'll get a lot of kind of messy expressions, some compound fractions with fractions inside of fractions. Keep in mind it's only Math 95. So here, this is kind of nice. Plus 1, subtract 1, I'm left with 12 over 12 over x. 12 over the fractional expression 12 divided by x. So let me simplify that compound fraction. This is 12 divided by a fraction, so same as 12 times the reciprocal of the fraction, and it gets a really nice cancellation. This isn't just luck that I got a nice formula like x out of this mess. It turns out that when you compose a function and its inverse in either direction, you're going to get x back. And the reason for that is that inverses are basically backwards functions, or functions that undo each other. So in this composition, you're doing h inverse, you input something and you do h inverse, and then you do the reverse function, the function that undoes it and takes it back to the original input x. And so there's a fact here that'll be real handy to know, that as long as this is well defined, h composed with h inverse of x is going to be equal to h inverse composed with h of x. In other words, the composition can go either direction, even though composition's not commutative. In this case it is. H composed with h inverse will be the same as h inverse composed with h. And in both cases, the formula for a function composed with its inverse in either direction will just be x. So that's very nice. Let's take a quick look, or not so quick look, at the activity again. And I'm going to dim the lights, and let's look at a few different problems on here. So we just did numbers 3 and 9 there. And now let me look at number 10, what that is asking. It's saying sketch y equals f inverse on the same axes with f of x. Let me zoom in even a little bit here. Okay, so let me go to this graph that has f of x drawn on here. Sorry, I've got the graph a little bit messed up with some other stuff, but maybe we can deal with that. I'll use a little different colored pen here. And let me look at what happens when I try to sketch f inverse on this graph. Let me look at a point on the graph of f. I'm just picking an arbitrary point. There's a point here at 0, -2. And because inverses flip-flop